Alright, sometimes we need to find the higher order partial derivatives. Okay, let me explain how we want to find the first order partial derivatives and the second order partial derivatives. Okay, let's say we have a function f. Okay, function f. So from the function f, we can differentiate with respect to x. So it will become the partial derivative with respect to x. Okay, fx. From the function f also, we can differentiate with respect to y. So it will become the partial derivative with respect to y. For second derivatives, from fx, we can also differentiate with respect to x. So it will become fxx. Okay, first differentiate fx, second differentiate with respect to x also. Okay, and from fx also, we can differentiate with respect to y. So it will become fxy. Okay, from the first derivatives with respect to x, second derivative with respect to y. Okay, from fy also, we can differentiate with respect to x. So it will become the fyx. Okay, first derivative with respect to y and then with respect to x for the second derivatives. And from fy also, we can differentiate with respect to y. So it will become fyy. That means we can differentiate function f, okay, with respect to y twice. Okay, right? Boleh faham nah? So we have function with two variable x and y. That means there are 4 derivatives that we can get. Okay, from the function of two variables, we can get 4 derivatives. Okay, boleh faham tak? Okay, I give you examples. Okay, let's say we have z equals to x cubed plus 4x power 5 y cubed plus 5y power 4. Okay. Okay, yang ni z saya, okay? Z saya. Z awak macam mana? Macam ni Okay, kekalkan dengan z awak macam ni. Okay? Tak ada masalah. Okay, yang ni z saya. Saya tak boleh nak ubah dah. Okay? Alright. So we need to find, okay, this is from my equations. Okay, I give you examples here. Okay, we need to find the partial derivative with respect to x. Okay, that means we need to find zx, zy, zxx, and zyy. Okay, zxx, zyy. Okay, and also zxy, zyx. Okay, so first we need to find the partial derivative with respect to x, zx. Okay, so differentiate x cubed, we get 3x squared plus 4, differentiate x power 5, we get 5x power 4. Y cube is a constant, fixkan dia, okay, kekalkan dia. And then 5y power 4, it is constant, okay, because we need to differentiate with respect to x only. So we assume this variable y, it is constant. So differentiate constant, we get 0. Okay, so 3x squared plus 4 times 5, we get 20x power 4 y cube. Okay, this is the answer, the partial derivative with respect to x. What about z xx? Okay, second derivatives with respect to x. Okay, that means from zx. Okay, from zx here. Okay, so 3 is constant, differentiate x squared, we get 2x plus 20, differentiate x power 4, we get 4x cubed, and then y cubed is a constant. Then you need to solve. 3 times 2, we get 6x, 20 times 4, we get 80x cubed, y cubed. So this is the answer for zxx. Okay, boleh nampak dah? Okay. What about zxy? Okay, second derivative with respect to y. Okay, from the first derivative, zx here. Okay, so second derivative with respect to y. Okay, 3x squared is a constant. Differentiate constant, we get 0 because it doesn't have a variable y. Okay, what about this one? 20x power 4 y cubed. 20x power 4, it is constant. Okay, differentiate y cubed, we get 3y squared. Okay, then we need to solve. 20 times 3, we get 60 x power 4 y squared. This is the answer. Alright. What about zy? Okay, zy. Okay, differentiate with respect to y. Okay, so x cubed, it is constant. Differentiate constant, we get 0. Okay, 4x power 5, it is constant. Differentiate y cubed, we get 3y squared. Differentiate 5y power 4, we get 4y cubed. Okay, and then 4 times 3, we get 12. X power 5, y cubed. 5 times 4, we get 20 y cubed. So this is the answer for zy. Okay, what about zyy? Zyy, that means from the zy, okay, second derivative with respect to y. Okay, so 12x power 5, it is constant. Differentiate y cubed, we get 3y squared plus 20. Differentiate y cubed, we get 3y squared. Okay, so 12 times 3. Is it correct? Okay, 12 times, oh sorry, this one is y squared. Sorry, y squared, right? Okay, so this one, so differentiate y squared, we get 2y. Okay, differentiate y squared, we get 2y. So 12 times 2, we get 24 x power 5 y. 20 times 3, we get 60 y squared. Is it correct? Okay. And then for z, y, x, second derivative with respect to x. Okay, from the zy. Okay, from the zy. So 12 is constant. Differentiate x power 5, we get 5x power 4. Y squared is a constant. And then differentiate 20y squared. Okay, 20y cubed is a constant because it doesn't have a variable x. Right? So differentiate constant, we get 0. So you need to solve 20 times 5, we get 60 x power 4 y squared. Okay, this is the answer. Okay, you found now? As you can see this, zxy, okay, zxy, it is 60 x power 4 y squared. Zyx, also 60 x power 4 y squared. It means zxy, it is equal zyx. Okay, nampak now? You found now? Alright. Okay, look at example 5.4. on your notes. Okay, example 5.4 on your notes. Okay, 5.4. Okay, let's say we have, okay, z, okay, y square sine x power 2. So we need to find what? To find the zy, zx and zxx. Right? Okay, example 5.4. Okay, so to find the zy, okay, the partial derivative with respect to y. So y square, differentiate y square, we get 2y. Sine x square, we assume as a constant. So it is fixed. The answer is 2y sine x square. Okay, what about zx? Partial derivative with respect to x. Okay, so y square, it is constant. Differentiate sine x square. Okay, that means we need to differentiate x square first. Differentiate x square, we get 2x. Differentiate sine x square, we get cos x square. Okay, so the answer is 2x y square cos x square. This is the answer. Alright. What about zxx? That means second derivative with respect to x from the zx. This one, from the zx, we need to find the second derivative with respect to x. Okay, so y square is constant. Okay, so it means 2x. Okay, 2x multiply with cos x square. We need to differentiate this one. Okay, as you can see, this is concept multiplication. So differentiate 2x cos x square. We need to use what? A product rule. We assume this one, we let 2x as u, this one as v. Use concept product rule. Okay, that means we need to use the formula of product rule. Okay, what is formula for product rule? vu prime plus u v prime. Right? So y square, it is fixed. Okay, and then you need to differentiate. Okay, using product rule. V is cos x square. Okay, u prime, that means you need to differentiate 2x. Differentiate 2x, we get 2. Alright, and then plus u. What is u? U is 2x. Multiply with v prime. V prime, it is cos x square, right? V is cos x square. So differentiate v. That means you need to differentiate x square first. You get 2x. And then differentiate cos x square. Differentiate cos x square, we get negative sine x square. Okay, you nampak no? And then you need to simplify. Okay, this one 2 cos x square plus 2x times 2x, we get 4x square negative sine x square. Okay, positive, negative. Positive, negative. It should be negative here. Okay, and then sine x square. So this is the answer. Okay, kalau awak tengok dalam jawapan dia, okay, for example 5.4, that means difactorizekan 2. Okay, dia bawa keluar 2. Okay, so it doesn't matter. Okay, tak ada masalah if you guys tak factorizekan dia. Okay, so this is the answer for example 5.4. Alright, boleh faham nah? Okay, I give you last example. Okay, this is from my question. Okay, last example. For higher order partial derivatives, let's say we have a function of xy, it is equal x squared plus y minus exponent y. Okay, so we need to find, let's say we need to find the partial derivative with respect to x. So differentiate x squared, we get 2x. Y is a constant, so differentiate constant, we get 0. And then differentiate, this one, exponent y also is 0. Okay, we assume as a constant because it has variable x. It has a variable y, not variable x. So we assume as a constant, differentiate constant, we get 0. So the answer is 2x. Okay, what about partial derivative with respect to y? So x squared, it is 0. Differentiate y, we get 1. Differentiate exponent y. Okay, this one is minus. Differentiate exponent y, we get back exponent y. Okay, let's say we have exponent 2y. So differentiate exponent 2y, it will become exponent 2y. Then differentiate to y, we get 2. So bring in front. Let's see. Okay, this is example for exponent form. Okay, and then so the answer is 1 minus e power y. Alright, what about we have a second derivative with respect to x. Okay, from the fx, this one fx, second derivative, okay, with respect to x. So differentiate to x, we get 2. That's it. Okay, what about second derivative with respect to y? Okay, from fy. Okay, from fy. So differentiate 1, we get 0. Right? So differentiate negative exponent y, we get negative exponent y. Okay, differentiate exponent y, we get back exponent y. Because of this one is negative, so negative. Okay, if positive, stick in positive. Okay, what about partial second derivative with respect to y? Okay, from the fx. Okay, from the fx, we need to find the second derivative with respect to with respect to y. Okay, fxy. Okay, so because of this one, variable x, it is constant, so differentiate constant, we get 0. Alright, boleh faham na? Tak faham boleh tanya dalam WhatsApp, okay?